In this video, we will solve quadratic equations using the quadratic formula. So let's take a look at x squared minus 5x minus 36 equal to 0. We know how to solve this. We know that we can figure out what multiplies to be negative 36 and adds to be negative 5 to be able to factor this problem. So we would get a negative 9 and positive 4, where we would figure out that those are our factors. So our factors would be x plus 4 times x minus 9 equal to 0. Then we know our zero product rule gives us x minus 9 equals 0 or x plus 4 equals 0, which gives us the x values of 9 and negative 4. And so those are our solutions, negative 4 and positive 9. Or we could use a formula called the quadratic formula. The quadratic formula is here. Our x values are equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula is used to find the solutions of any quadratic equation. So this formula is always an option to be able to solve. So let's solve that equation that we just looked at, where we know our solutions should be 9 and negative 4, and see if we get that using quadratic formula. All right, so our first step to do this is to make sure the equation is set equal to 0, which it is, and is written in standard form. Remember, standard form is ax squared plus bx plus c. And so the equation is in standard form. Our next step is to identify our a, b, and c values. So I have these little placeholders here. What's the coefficient of our x squared? It's 1. Coefficient of our x term is negative 5. And our c is negative 36. It's these a, b, and c values that then get plugged in to those places in the quadratic formula. So x equals negative of b, which is a negative 5, plus or minus the square root of negative 5 squared minus 4 times a times c. So I'm just taking those values and plugging them in all over to a. From here, what I have to do is I have to simplify this expression. So notice here I have the negative of a negative 5. That's going to become a positive 5, plus or minus the square root of negative 5 squared is 25, minus 4 times 1 times negative 36. I have to do the multiplication before I do the subtraction. So 4 times 1 times 36 gives me 144. And 2 times 1 in the denominator just gives me 2. Now I need to simplify this. So I'm using order of operations. I need to add the 25 and 144 together to get 169. Now I can take that square root, and that's going to give me 13. So here, notice I have 5 plus or minus 13 equals 2. So that means I really have my two solutions, one where I'm adding 5 and 13, and one where I'm subtracting 5 and 13. So my solution will look like 5 plus 13 over 2, or 5 minus 13 over 2. And that's going to give me my two solutions. So what is 5 plus 13? That's 18 over 2, which gives me 9. 9 was one of my solutions that we started with. 5 minus 13 is negative 8, divided by 2 gives us negative 4. So we ended up with the same solutions that we got by factoring, by using the quadratic formula. So let's try a couple more examples. Okay, so here I have 3x squared minus 4x equals negative 4. So first we have to make sure it's equal to 0. It's not, and it's not written in standard form. So we need to add 4 to both sides so that now our equation is in standard form. Identifying our a, b, and c. A is 3, B is negative 4, and C is positive 4. Now I need to plug those into the quadratic formula. So B goes here and here, A goes here and here, and our C value goes here. Now I'm ready to simplify. So negative of a negative 4 becomes positive 4. 4 squared is 16. Minus 4 times 3 times 4 is minus 48. 2 times 3 on the bottom is 6. Now I'm going to subtract 16 minus 48, and I get a negative 32. If I try to take the square root of negative 32, there's not a number multiplied by itself that's going to give me a negative value here. So that means that I can't take the square root of this negative 32 without getting a number that's not real. And so that means that this has no real solutions. That means that our value for our solution isn't real. If you were to look at this on the graph, you would see that this one doesn't touch the x-axis. Think about when we looked at the discriminant. Remember, the discriminant was b squared minus 4ac, and that determined how many solutions we were going to have. If that discriminant was negative, that meant that we weren't going to have any x-intercepts, that there were no real solutions. All right, let's take a look at 5x squared minus 2x minus 1 equals 0. It's already in standard form, so we can identify our a, b, and c. So a is 5, b is negative 2, c is negative 1. Now I can plug in our values. I have negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, now I'm ready to simplify what I can. Negative of a negative 2 becomes a positive 2. 2 squared is 4. 4 times 5 times 1 is 20. And 2 times 5 is 10. I add the 4 and 20 together, and I get 24. Here, I can take the square root of 24, but it's not perfect. So I have to simplify the square root of 24. So remember how to simplify radicals, looking for that perfect square underneath. So I have 4 times 6, and I pull out that 2. From here I have to consider 2 plus 2 root 6 and 2 minus 2 root 6 over 10. But I can't combine that 2 and 2 root 6. But I can simplify 2, 2, and 10 all by a factor of 2. So I have 1 plus or minus 1 root 6 over 5. What I've done is I've simplified that fraction to get rid of that factor of 2. Now from here I can separate my two solutions. I have one where I have 1 plus root 6 over 5 and 1 minus root 6 over 5. And those are my two solutions. I can't combine 1 and root 6 here, so I leave the expression just as it is. This is my solution. There's nothing to do to it. All right, our last example here. 2x squared plus 7x plus 3 equals 12. Make sure it's in standard form. So I needed to subtract 12 from both sides, and now I have c is negative 9. b is positive 7, and a is positive 2. Now let's plug in those values. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, now I'm ready to start simplifying. I have a negative of 7, so that becomes negative 7. Plus or minus 7 squared is 49. And negative 4 times 2 times negative 9 becomes 72. Over 2 times 2, which is 4. So here I get negative 7 plus or minus the square root of 121 over 4. And so that gives me negative 7 plus or minus 11 over 4. So remember that this means I have two solutions, negative 7 plus 11 and negative 7 minus 11 over 4. So my first solution, negative 7 plus 11 over 4, gives me 4 over 4, which is 1. So one of my solutions is 1. My other solution is going to be where I subtract negative 7 minus 11 over 4, which gives me negative 18 over 4, which simplifies to negative 9 halves. So my two solutions are negative 9 halves and 1. Remember, the quadratic formula works for any quadratic equation. So you'll have your two solutions, one solution, or no real solutions here when you finish putting in the quadratic formula. You can use this little template here as a way to keep track of where to put your A, B, and C.